The last thing we have to do before we move on to a new topic next week, we need to be able to solve fractional equations. Now that basically means just one thing, but there's 2 points that we want to make sure that we cover here. First of all, we're going to find the solution to equations that are algebraic fractions. But along with that, we have to make sure that we note the restrictions and make sure that one of our answers isn't a restricted value. The first thing we'll do when we see an algebraic fraction, or an algebraic equation, a fractional equation, the first thing we'll do when we see a algebraic fractional equation is find the restrictions, and then we just make a note of them so that then later on when we solve, we check our solution and make sure they're not on that restricted list. Okay? Well, we've done some of this already. We've done the type where the denominator does not contain variables because those are linear. Okay? So we're going to use the same principle we used to solve that. We did that a couple of weeks ago. Take a minute and think about how we solved this one, because the technique we're going to use for this is going to be the same technique we use even if there is a variable in the denominator. Find your common denominator, that's right. In this case, what is your LCD? 16. Okay, so you find your common denominator, it was 16. Then what do you do with your common denominator? Multiply every term by the LCD. That doesn't give us common denominators, it clears the fractions, right? That'll, if we've chosen the right LCD, wipe out any fractions and we'll have an equation that doesn't involve fractions. So we'll multiply this term by 16, we'll multiply this term by 16, and we multiply this term by 16. Okay? What's going to happen when you cancel? You get 8. Okay, so there it is. It's just that by doing it this way, now there's no denominator left, as opposed to still having it over 16. Well, if they're all equal to 16, then the numerators have to be equal. So we clear them. We don't rewrite them with a common denominator like we had to when we're adding and subtracting them. We just clear them all together. So this one becomes 8 times 3x minus 4 minus, here, they cancel completely. That reflects the fact that if you wanted a denominator of 16, you wouldn't have to multiply the top of this one by anything. You could just leave it as it is. So minus 3x minus 1 equals 16 over 8 is 2. That reflects the fact that we'd have to multiply both the top and bottom by 2 in order to get 16 down here. So that's 2 times 6x minus 5. Okay? So now we have no fractions left. Do you see the difference between what we were doing yesterday and trying to solve it? Yesterday, you didn't have an equation. You just had an expression and you needed to find the total. Well, then you have to keep the denominator. But as long as it's an equation, we can clear the fractions right out of there to make it easier to solve. Okay, well, let's solve this. 24x minus 32 minus 3x plus 1 equals 12x minus 10. And you could combine all your like terms here. If you do all that, you're going to end up with 9x equals 21. Solve for x, and we get x equals 21 over 9, which reduces to 7 over 3. And we solve that one. Well, that's the same principle we're going to apply to algebraic fractions where there's a variable in the denominator too. Incidentally, what were your restrictions on this algebraic equation? Are there any restrictions on x? There's none. There's no way any of these denominators can be 0. They're all fixed, and so there's no restrictions at all. Okay. Well, we're going to solve this in a minute, but first let's just answer this question. We need to tie these two ideas together here. What are the restrictions on 2x plus 8 over x plus 4 equals 1/2? Well, what's your only restriction here? That's right. X cannot be equal to negative 4. Since x plus 4 can never be equal to 0, then apparently x cannot equal negative 4. So there's our restriction. No restriction, x minus 4, that cannot be a solution to that equation. No matter what, period. So now we're going to go ahead and solve that. And hopefully we'll get some solution other than negative 4, because then it's okay, then it's fine. I'm just going to make a note up here that x cannot be equal to negative 4, the restriction that we just noted. Sorry, what was your LCD? 2 times x plus 4, that's right. So the left side we're going to multiply everything by. We're going to multiply everything by 2 on the everything by 2x plus 4 on the left side. The reason we do that is what's going to happen to the x plus 4s? They cancel off. We cleared off that fraction. And on the right side, we're going to multiply everything by 2 times x plus 4. And what happens over there? 2's cancel. So our new equation has no fractions in it. That's the idea. Our new equation becomes over here, we've got 2 times 2x plus 8 equals x plus 4. Well, that's not a bad equation to solve, Grant. So if we solve that, we get 4x plus 16 equals x plus 4. So subtract x, we get 3x. Subtract 16, we get negative 12. And apparently x equals, oh no, negative 4. But what's the problem with that? It can't be negative 4. You can't say, oh, a negative 4 makes this equation true. Well, no, it doesn't, because you can't plug negative 4 into that. Since this is the solution, there are now be careful with no solutions. It's kind of like prime. If you're asked to do some factoring, and it's a little bit tricky, don't just write prime. It's just a problem just because it gets a little ugly. In this case, there's legitimately no solutions. We found one, but it's restricted, so that can't be it. Now, that does not happen often. Okay, well, let's do a few more. Does that make sense? We solved it. The only solution we got, though, was a restriction, so there are no solutions. Okay. Well, that's it. That's the material. Now let's do a few examples, though, to hammer it out. Now, if you look at this next problem, what's the first thing that your eye should glance to for direction as to what to do? What's the first thing that you should notice? Nope. Even before that. Even before that. Even before that. Nope. Before that. Equal sign. As soon as you see the equal sign, you're thinking x equals something. I need to find what x equals. I got to find a number here. 3 over x plus 2 equals 5 over x plus 4 over x squared plus 2x. To save a little bit of time and space, I'm going to write that on the board while factoring it. Let's make two notes here. First of all, what are the restrictions? -2 and 0. Here, x can't be -2. Here, x cannot be 0. And here, same ones, -2 and 0. Okay, so those are our two restrictions. Hopefully, we will get solutions other than -2 or 0. Okay, let's make another note here. What is our LCD? X times x plus 2. Those are the two things we need to start with. Before we begin solving, we've got to establish those two facts. Okay? Now, what do you want to do? It's an equation. We're looking to solve for x. So, do we want to keep the fractions or do we want to clear them off? Clear them off. Multiply every term by the LCD. So this is going to be 3 times x times x plus 2. This is going to be 5 times x plus 2. And this is going to be 4 times x plus 2. Now, you will always have a gob canceling because your fractions have to disappear. That's the whole point of doing this. The first term becomes what? That's right, 3x. This term becomes 5x plus 2. And this one, 4. Now that's an easy equation to solve. Okay? Well, does that look all right? We found the LCD. We multiplied every term by the LCD. It'll clear all your fractions, and what's left will never be too tricky to solve. Now, we can finish this out without too much difficulty. We get 3x equals, I'm going to save a couple of steps here just to save a little bit of time. 5x plus 10 plus 4 is plus 14, which means -2x equals 14. So apparently x is equal to -7. Now, we can't quit because we need to make sure to check the restriction. Was that a restricted value? Nope, it's fine. So this is our solution. It's okay. Let's look at another example. In order to save a little bit of writing and a little bit of time, we'll factor each of the numerators and denominators as we rewrite this equation. Our first term, x plus 1 over 2x minus 2. The x plus 1 will not factor, though 2x minus 2 will. We can factor out a 2. And we're left with 2 times x minus 1. From that, we'll subtract the algebraic fraction x minus 1 over x plus 1, which of course we cannot factor. And that has to be equal to 17 minus x squared, which will not factor, over 2 times x squared minus 2. Now that's the same as 2 times x squared minus 1. Note, however, that x squared minus 1 will factor even more. We can rewrite this as x plus 1 over 2 times x minus 1 minus x minus 1 over x plus 1. And that has to be equal to 17 minus x squared over 2 times, now if we factor that difference of squares, we have x plus 1 times x minus 1. Now let's determine what our LCD here is so that we can clear off all of our fractions. The LCD is going to be 2 times x minus 1 times x plus 1. Okay, now we're going to multiply each one of these three terms by the LCD. We'll cancel off and we won't have any fractions left. So if we go back up here and we multiply, excuse me, we multiply the numerator by 2 times x minus 1 times x plus 1. We'll do the same thing to the second term. And we'll do the same thing to our last term. Now, by doing that, we're going to get a bunch of cancellation. Let's take a look at this first term. First of all, the x minus 1s will cancel off, and the 2's will cancel off. That leaves us with x plus 1 times x plus 1. The second term, the x plus 1 will cancel, and we're left with 2 times x minus 1 times x minus 1. Now we could write that as x minus 1 squared, but since we'll need to multiply it out anyway, we'll just leave it factored here. And for the last term, the 2's cancel, the x plus 1's cancel, and the x minus 1's cancel. And so we're left with simply 17 minus x squared. So this is our new equation. There's no fractions left. Now, let's go ahead and perform any multiplication that's necessary and solve the equation. So if we FOIL these two binomials together, we get x squared plus x, that's plus 2x, plus 1. You can verify that multiplication if you'd like. And we're going to subtract off 2 times. Now we'll multiply these two binomials together and we'll get x squared minus x for our outside terms, minus x for the inside terms. That's minus 2x plus 1. And that has to be equal to 17 minus x squared. Okay, continuing on, we now have x squared plus 2x plus 1 minus 2x squared plus 4x minus 2. Let's combine like terms on the left side. We have x squared minus 2x squared. That leaves us with negative x squared plus 2x plus 4x. That's plus 6x. And 1 minus 2 is negative 1. That has to be equal to 17 minus x squared. Now if we add x squared to both sides, we end up with 6x minus 1 equals 17. Add 1 to both sides, and we have 6x equals 18. So apparently we have a solution of x equals 3. Now we don't know for sure that that solution is valid because we have not gone back to look at our restrictions. Let's go back and look at what our restrictions were on the original equation. Going back to the original equation, we can't have a denominator of 0. X minus 1 yields one restriction, and we note here that x cannot equal 1. Here, from this denominator, x plus 1 cannot equal 0, so we have to recognize that x cannot equal negative 1. And x squared minus 1 factored into x plus 1 and x minus 1, so we have the same two restrictions. Our two restrictions are x cannot equal 1 and x cannot equal negative 1. There's no conflict there with the solution we arrived at, and so x equals 3 is the correct solution to this equation. The last one we're going to do is a literal equation. All the same principles are going to apply, but here all of our terms or all of our values are variables. Well, what do we need to do first? Solve for A? Nope. But you are watching A because you got to look for your restrictions. You got to watch your restrictions. Now the good news is that the restrictions are on A. And that's really not a problem because we're not solving for A, we're solving for X. But let's make a note of them anyway because it's good practice. Here your restriction on A is 1. So we'll make a note here that A cannot be equal to 1. Also, A cannot be negative 1. Well, our solution is going to be for X, so that won't be a problem, but it's always good to recognize them. Okay, now we want to solve this for X. So we want to clear all of our fractions. So that means we need to know our LCD. And the LCD is? A minus 1 times A plus 1. So there's our common denominators. Now we're going to multiply every term by that LCD. All of our fractions will disappear. All right. So let's do that. So this one will be X times A minus 1, A plus 1. Okay, would you agree with that? Now, cancel away, our fractions better disappear. First term, what are we left with? X times A plus 1, right? Next term is minus, don't lose that negative sign, minus X times A minus 1, and that's equal to Okay, remember we're solving for X, so now what do we need to do? Yep. Distribute it out, multiply those X's. So we could ultimately factor out X, but that would be a more confusing way. Let's just distribute our X's in. So this becomes XA plus X minus XA plus X equals now that works out nicely. What happens over there? Those annihilate each other, so really what does this whole left side become? 2x. So 2x, everybody see where that 2x comes out? Everything else kind of cleans up. And so we're basically done now. Last step. Divide by 2, and we're left with our solution. X equals b times a minus 1 times a plus 1 over 2. Now our restrictions really don't apply because x can be this mess. We're not told that x can't be anything, so we're really done. There's no restrictions to check here since there's no restrictions on x itself.